Hello, kids, and welcome to the special Halloween edition of Honors Chemistry Notes. Today, we're going to be taking a look at formula weights. If you think this is scary, this is as scary as it's going to get because today's lesson is actually quite simple. If you can read a periodic table, multiply, and add, you're going to be A-okay. This will be the last section of notes that we will encounter here for chapter 3 before the super quiz next week, the day that you arrive back. Without further ado, I'm going to take this mask off and turn off the music because I got to get into my glasses and so I can read my notes. Okay, let's turn the music off and let's stop with the crazy voice. All right, I'm going to go turn the light back on. All right. So I hope that did not frighten any of you too much. Okay, Halloween is one of my favorite all-time days, months, periods of time during the year. I always joke that I get 1 month out of the year. My wife gets the other 11. I get October. She gets the rest. So this is my time to shine and live it up. And it's also coming to a close. So like I said, this is the Halloween edition. That's about as Halloween as it's going to get. You're going to be seeing this video on the 30th. So the day before Halloween, the day before trick-or-treating. Hopefully you all get some good candies and snacks when you go trick-or-treating. If you go trick-or-treating. I don't know. I would still go if I could. So anyway, back at the notes here. Talking formula weights. This will be a somewhat short in terms of content video, but we'll be doing some practice stuff. And so, like I said, with my wonderful mask on, we're going to be simply multiplying and adding values today. And we might do a little bit of dividing, possibly. But like I said, pretty straightforward content today. So we're going to be talking about formula weights, also molecular weights, and really there's no difference in how you calculate them. You'll see how the book describes their difference. It's really nothing in terms of method. And then we're going to be looking at how we can determine the percent composition of a particular element within a molecule itself. Okay, how much of the overall mass of the molecule does a single element take up? So without further ado, let's start in on here. What is a formula weight? First of all, we abbreviate it with FW. It's the sum of the atomic weights for the atoms in a chemical formula. So basically, if we can look at the atomic mass of each element in the periodic table and then look at the formula, we can do this rather simply. All right. So let's look at calcium chloride. Calcium chloride, it's an ionic compound, formula CaCl2. Okay, that means that there is one calcium. Let me get my pointer here. There's one calcium and two chlorines. So we need to figure out how much does calcium chloride weigh? Okay, what's its overall mass? So basically, looking at the periodic table, you see that an atom of calcium has a mass of 40.08 AMU, and that there is one present. So calcium comprises of 40.08 AMU of the overall mass. Chlorine, there are two present, as we see in the subscript here. And if you look at the periodic table, chlorine has a mass of 35.453 AMU. So what you need to do is whenever you see a subscript here, you're going to take that subscript and multiply it by the atomic mass as reported on the periodic table. And so you take your calcium, you take your newly calculated mass of Cl2, and you sum them together, and you get a formula weight for calcium chloride of 110.99 AMU. Again, don't forget the AMU. On our last quiz, some of you forgot to list AMU, and you got deducted for it. I made a big emphasis on that. Anyway, here's the difference that your book describes between formula weight and what we'll see as molecular weight. Formula weights are generally reported for ionic compounds. Okay, Molecular weight is generally reported for covalent compounds, okay, nonmetals coming together. The process is really not different whatsoever. So, so don't get caught up on that. Secondly, you're going to see here that this example gives the exact value that is reported on the periodic table with decimal values. You might see me do a couple practice ones like that, but if you want to just go ahead and round the number so your numbers are nice and clean and not a whole lot of decimals, by all means, okay? The difference isn't really going to be all that much. So you'll also see me do rounded versions. It's completely up to you. Either way is fine with me. Okay, so let's look at calculating some formula weights here. Okay, the first one is sucrose. If you follow my pointer here, C12H22O11, which is basically table sugar. And then the second one we're going to do is calcium nitrate, CaNO3-2. Let's go back to A, table sugar. So again, we have carbon, we've got hydrogen, and we've got oxygen present here. We have 12 carbons, 22 hydrogens, and 11 oxygens. So if we go and look at the periodic table, you'll see they have already gone into the rounding of the atomic masses as reported on the periodic table. So ta-da, you get to do the same. So again, there are 12 carbons, so you take 12 times the mass for 1, so it's 12 times 12, you get 144 AMU. 22 hydrogen atoms, hydrogen has a atomic mass of 1. And then oxygen has an atomic mass, or rounded atomic mass of 16, and there are 11 present. So you take, back up here at carbon, 12 times 12. For hydrogen, 22 times 1. And for oxygen, 11 times 16. And once you get those products here, you sum them up, and you get an overall formula weight of 342.0 AMU for sucrose. Moving on to calcium nitrate, the same process, okay? Calcium, there is 1. Nitrogen, so you're going to break these up into individual elements. Nitrogen, there are actually 2, because if you look here, the NO3 has a subscript of 2 on here. So you're basically going to multiply that 2 by the amount present in the parentheses. So there are 2 nitrogens present in this formula. For oxygen in the parentheses has a subscript of 3. So you multiply that 3 by the subscript of 2 on the outside of the parentheses, and you have a total of 6 oxygen atoms. So once you've determined how many atoms of each element are present, you go ahead and multiply them by their atomic masses, sum them up, and you will find that 164.1 AMU is the overall formula weight for calcium nitrate. Now, I'm not certain why the book decided to toss in a decimal point. It's a rounded decimal point because we just saw this as like 40.08 or 40.09, 40.08, okay, and they went ahead and rounded it. I don't know, okay? Just make this a nice 0 if you want to, okay? So let's look at how we solve our own questions here, okay? I've got to get out of here. I've got to rotate myself, upside down, and we're going to get directly into here. I'm going to dim this back that way, dim this just a little bit so you can see a little better. And we are going to do this work. Okay, so going back to the question here, calculate the formula weight of A, aluminum hydroxide, and it has a formula of, here, let me get this back over here. It has a formula of AlOH3. Again, we got that formula because it's an ionic compound. We have a metal and a polyatomic ion, and so we follow the appropriate procedures. We do the whooping, and then we move forward. So aluminum, if you want to pause and take a look at the periodic table, aluminum has a rounded value for a rounded mass of 27.0 AMU. Oxygen has a rounded atomic mass of 16.0 AMU. And hydrogen, okay, has a rounded atomic mass of 1.0 AMU. But if you'll notice from the formula, and I've already made a mistake here because I got so caught up on my Halloween stuff that I neglected to do something. Do you know what that something is? Silly me, forgot to put the 3 through to the oxygen. Okay, so I'm just going to kind of clean this up. So I'm going to put the 3 there. I was getting ready to do it on the hydrogen until I'm like, duh, we got to put it on the oxygen too. So there we go. We have 3 oxygens and 3 hydrogens present in this one compound, in this one molecule. So after you multiply this through, you get 27.0. 3 times 16 is 48. Don't forget AMU. Okay. And 3 times 1, hopefully that was a non-calculator one for you. And so you go ahead and add these up. You get 3 plus 48 is 51, plus 27, you get 78.0 AMU. And that's it. That's how your answer would be for A, 78.0 AMU. Let's do another example here. All right. Let's look at B. I'm not going to screw up on this one, I promise you. Okay, CH3OH. Excuse me. CH3OH. So again, we've got carbon, we've got hydrogen, and we've got oxygen. Okay? So now let's count how many we have here. Carbon, we've just got the 1 here. So if you are comfortable putting the 1 there, you can go ahead. You don't have to. Hydrogen, there are 3 here plus 1 more. So that gives us 4. And there is 1 oxygen. Carbon, its rounded atomic mass is 12.0 AMU. Hydrogen, again, is 1.0 AMU. And oxygen is 16.0 AMU. So go ahead and multiply what you need to. So here we have 12 AMU for carbon, 4.0 AMU for hydrogen, and 16.0 AMU for oxygen. Once we've got those products all ready to go, we sum them up, and we get 32.0 AMU. That's it. That is how you calculate formula weights for compounds. Okay? So let's get back into our notes here and kind of go a little bit different in terms of, well, I kind of want to get it not so dark on me. There we go. That should be better. All right. Oh, now it's really bright here. Ah. Sometimes if I could do this, maybe it'll adjust the camera. Nope. Okay. Let's stay that way. Anyway, let's get back into our notes. So again, molecular weight is the sum of the atomic weights of the atoms in a molecule. C2H6, its molecular weight, non-rounded, would be 30.070 AMU. Okay. Same process as finding formula weights, except these molecular weights are typically reserved for molecular compounds. So those that do not contain metal. All right. So this is actually, this C2H6, its formula is for ethane. So keep that in mind when we come back to it. Okay. The last thing we're going to talk about is percent composition. And so we can find the percent of mass of a compound that comes from each of the elements in the compound by using the following equation. Okay. So again, I'm just going to write this down on my dry erase board so we can come back to it. Percent element. Okay. So we have the percent of the element is going to equal the number of atoms multiplied by the atomic weight of that particular atom and divide that by the overall formula weight of the compound. Okay. So in short, if you are not told what the overall formula weight or molecular weight is for a particular compound, the first step is you have to calculate it yourself. Okay. Then you can proceed on to finding the overall percent composition of each element. So, for instance, Going back to ethane, again, it's at C2H6. Okay. In this slide, we are told what the formula or molecular weight is, 30.070. In fact, you can probably just round that off to 30 AMU if you want to. So if we want to figure out what percent of carbon is present in a molecule of ethane, we set it up like this. Okay. So again, again, the formula, I want to write on here. How about we write this? So the formula, again, was C2H6, okay? There are 2 carbons in a molecule of ethane. And so we take the number of atoms present, that's 2, multiply it by the atomic mass of that particular element, so carbon in this case. They didn't use the rounded numbers, still feel free to use the rounded numbers. And they divide that by the overall molecular weight of the compound ethane. And so when we take the 2 and multiply by 12.011 and then divide it by 30.070, we are then going to also take that and multiply it by 100, which gives us a percentage. So of the overall formula weight of ethane, carbon makes up 79.887% of its overall mass. So that's how we calculate percent composition. And as you probably guessed it, we are getting ready to do a couple practice questions. Yeah. All right, let me get my arrow back here and let's get into calculating the percent of carbon, hydrogen, and oxygen in the compound C12H22O11, which we just saw was sucrose. So we can kind of backtrack a little bit and use the already calculated formula weight that we saw a few slides ago for sucrose. So this one is asking for all 3 percentages of the elements in this compound. So it's all the same step, okay? So for carbon, we see that in the formula there are 12 multiplied by 12 AMU divided by the overall formula weight that we saw a couple slides ago, 342, and multiplied by 100%, you get percentage of 42.1%. Same thing for hydrogen, okay? There are 22 present, multiplied by its atomic mass, divided by the formula weight of the compound, multiplied by 100, 6.4%. And lastly, to round out the remaining percentage, for oxygen, there are 11 present, 16 AMU for a single atom of oxygen, divided by 342, multiplied by 100, you get 51.5%. Now, because we are rounding a little bit, there may be a situation to where all of your percentages may be less or slightly more than 100%. It's okay, because again, you are rounding. That's a very good possibility that you're going to encounter something like that. All right, let's look at the next practice exercise. Calcium nitrate, CaNO3 2. Okay. Calcium nitrate was given to us earlier, but as good practice, we're going to go ahead and redo this. Okay. So, excuse me. So if we look at the periodic table, let me get back into All right, I'm back. I'm back, folks. Oh, you can't see anything. I know what happened. I put it all the way up. Not sure what happened there. Anyway, so calcium, nitrogen, and oxygen. All right. So first, looking at the periodic table, we know that there's going to be 1 calcium, and there's going to be 2 nitrogens, and 3 times 2 is 6 oxygens. Okay. Calcium's rounded atomic mass is going to be 40.0 AMU. And just for fun, I'm going to double check here because okay, sorry. I just had to check real quick, make sure I had the right numbers here because I don't want to screw up again. nitrogen is going to have a atomic mass of 14.0 AMU. And oxygen, we've already known, is going to be 16.0 AMU. So we got to find the product here first. So this is going to be 40.0 AMU for calcium. For nitrogen, it's going to be 28.0 AMU. And for oxygen, it's going to be 96.0 AMU. Summing these all together, we have 164.0 AMU. Okay. So now that we have our formula weight for calcium nitrate, we can go ahead and calculate the percent composition of nitrogen that is asked of us in the practice question. Okay, so again, percent of element, which is going to be nitrogen, is going to be equal to the number of atoms. So again, looking at the formula here, Ca parentheses NO3 close parentheses 2, how many nitrogen atoms are present in a molecule of calcium nitrate? If you said 2, you're a winner. Okay? Next, we then multiply it by the atomic mass of a single element of nitrogen, single atom of nitrogen, and that is 14.0 AMU. We then divide it by the overall formula weight of calcium nitrate, which is 164.0 AMU. And then our last step would be to multiply it by 100%. So, if you want to pause the video, you can go ahead and calculate this yourself. Okay? I'm going to actually give you just a few seconds for you to look this up and calculate it. I'll continue to talk to you a little bit as we go through here. All right. So I was trying to find my aha, there's my calculator. So take your 2 times 14 is equal to 28 divided by 164, okay, times 100. You get a rounded answer of 17.1%. So the nitrogen within calcium nitrate makes up 17.1% of the overall mass of a single molecule of calcium nitrate. And that's that. And with this, you will receive some additional practice. Let me kind of get you back up here. You'll receive some additional practice regarding formula weights and percent compositions, okay? That's coming your way. If not with this video, then it'll most likely be in the next assignment that's going to be posted for the next class day. But that wraps up our discussion for section 3 here. Now, coming in section 4, okay, hopefully you recognize this term moles, or maybe even the name Avogadro. You have encountered this concept before. I know this because when I teach Intro to Chem Phys, I teach this, and so does Mr. Serbeck, and so does Mr. Hampton. So I know you've seen it. Whether or not you try to block it away from your memory, I don't know. Really, it's just a different version of math that we've already seen here, okay? And for some reason, right before I was getting ready to say what it was, it kind of, dimensional analysis, there we go. Whew. Got that figured out real quick on the fly. It's really just a different version of dimensional analysis, okay? Where instead of focusing so much on transitioning between units, we're going to be trying to determine how many molecules are going to be present in a certain amount of substance, how many atoms will be present, how many atoms of a single element could be present. So it's going to be that same way, very dependent on how we set it up. But again, the style is going to be very familiar to you. Okay, so be on the lookout for the additional practice of the percent composition and formula weights coming your way. It may be in an additional video as well, just trying to give you a heads up, if you will, or a practice video. And then that'll end it before our super quiz. Again, super quiz will be over the first 3 sections the day you come back, and it'll be on paper. So if you are a remote student, I need you to contact me here very soon to determine when you're going to come and take that super quiz. Anyway, it's been fun. It's been real. Always know that in this Halloween haunting season, that there's nothing scarier than a student who doesn't study. Make sure you study for this, folks. It'll be good for you. Anyway, with that being said, it is Mr. Dorfler. I am signing off for the day. Have a good one.